Very good morning, students. So, today's session, let us see about the gray body radiation. Gray body radiation. So, which we have not seen in the class. Directly after seeing the things, we have gone into the problem. So, radiation heat exchanger between two parallel infinite gray surfaces that we are going to see now. So, there are two surfaces. Just imagine as shown in the diagram. Surface 1 and surface 2. Surface 1, the temperature is T1. At the surface 2, the temperature is T2. When the heat is given in a point from surface 2 to surface 1, which is transferring heat to the surface 1 and reflecting from surface 1 to the surface 2, and again it is reflecting from surface 2 to 1 and 1 to 2 simultaneously. You can see this transfer of, you can notice that this one from 2 to 1 and 1 to 2, again 2 to 1 and 1 to 2. So here this concept is purely based on the reflection. So when surface 1 not transferring heat to the sides, that means this side, it is not transferring to this side, it is not transferring, hence it is reflecting this side, So when it is reflecting this side, the surface 2 again reflecting the another side. So this is the reflection, radiation. Due to radiation, the heat is transferring. So actually there is no perfect insulator, we all know already. It is reflecting to another side. Emissivity which is equal to the concept of this one. Okay. So we can see this reflection, so that E1 which is equal to emissivity and sigma T1 power 4. This is nothing but Stephen Boltzmann law. Just we see. Same way, that emission which is equal to emissivity to sigma T2 power 4. That is for the plane 1 and plane 2. So the radiation heat flow emitted by 2 and the Q will be heat flux will be E2 emissivity 1, E2 1 minus emissivity 1, product of 1 minus emissivity 2 plus E2 1 minus emissivity 1 power square, 1 minus emissivity square plus also 1, 2 to 1. It's keep on emitting the values. The RHS term is a generating progression. So Q 2 to 1 which is equal to E2 emissivity 1 by 1 minus emissivity 1 minus emissivity 2. So again Q 2 to 1 which is equal to E2 emissivity 1 divided by 1 minus emissivity 2 minus emissivity 1 plus emissivity 1 emissivity 2. So these all because of transferring heat between 1 and 2 only, and E2 to 1 which is equal to emissivity 1 divided by E1 plus E2 minus E1 into E2, which is equation number 2. Further it can be utilized to get the final equation Q122 equal to E emissivity 2 divided by emissivity 1 plus emissivity 2 minus emissivity 1 emissivity 2. Radiation heat flux emitted by 1 which is equal to Q122 emissivity 1 emissivity 2 plus E1 1 minus E1, as like the previous equation, the equation which is getting into the form of 4. So if T1 greater than T2, net radiation between 1 and 2 becomes as Q122 minus Q221, which is equal to Q net E1 capital E2 minus E2 capital E1 divided by E1 plus E2 minus E1 E2. So the E1 equal to emissivity 1 sigma T power 1 power 4. So E2 equal to same like the Stephen Boltzmann law. So Q net becomes as based on this equation U1 E2 sigma T1 power 4 minus T2 power 4 E1 plus E2 minus E1 E2. So this is about the radiation between, that is, gray surfaces. Radiation heat exchange between two gray parallel infinite surfaces. Thank you very much.